So here we're going to look at compound interest and in fact other compound changes. What do we mean by compound? Well, it's where we keep multiplying. Okay, so the interest is added to the interest or takes effect on the interest. And I always use a decimal equivalent of the percentage we want. And when we're multiplying more than once, remember that if we multiply by m 3 times m times m times m, that's the same as times m cubed. So do use that because it's much easier, especially when we're doing reverse percentage questions. Otherwise, we do exactly the same as we normally do. And if you remember from previous tutorials, it goes like this. Do have a quick look at that or have a look at the previous tutorials. So let's do a question. What are we doing? Well, we're looking at a savings account which has compound interest of 4.5% per annum. Okay, and so that means that each year we multiply by, or each year we want 104.5% of the previous year, and the decimal equivalent of that, in other words, the multiplier we're going to use is 1.045, which of course is 104.5% because percent means divided by 100. And so after 1 year, we multiply by 1.045, and after a second year, etc. We just keep multiplying by 1.045. So after 4 years, the amount of money is going to be the 5,000 euros we started with times 1.045 times 1.045 times 1.045 times 1.045, which is 1.045 to the power of 4. And if we put that in our calculator and round to the nearest euro, we get 5,963 euros. So that's a straightforward compound interest question. Let's look at a compound decrease question, but also a reverse question, because here we're told that a car loses 20% of its value each year, and we're told what it's worth 3 years after it was bought. And so to try and find the value when it was new, we need to use the sort of reverse percentage idea. Well, the way I do these is I always actually just write down the sort of correct statement and then solve the equation. So it loses 20% of its value each year. So each year we want 80%. And the decimal equivalent of 80% is, of course, 0.8, because that's 80 over 100. And so the value after 3 years is, well, it's going to be the new value, which we are actually trying to find, times 0.8 times 0.8 times 0.8, which is times 0.8 cubed. So I've got my after and before statement here, and now I just put in the numbers. So I can say 25,600 is equal to the new value times 0.8 cubed, and to find the new value on its own, I just divide both sides by 0.8 cubed. And so the new value will be 25,600 over the 0.8 cubed. And if I put that into my calculator, I get a nice round $50,000. And because it's a nice round number, I'm pretty sure I'm right. And so we move on to the hardest type of question, where we're asked to find the percentage rather than anything else. And so we've got Lionel, who's bought a house for £150,000 in 1984, and 20 years later he's had it valued at £1 million. And we're asked what annual rate of compound interest this is equivalent to. Well, let's sort of set it up in the same way. So each year we want, well, what do we want? Let's give it a name. Let's call it M%, okay? And that's going to be my multiplier. All right, that's going to be the decimal equivalent. And so we can say the value in 2004 is going to be the value in 1984 times, well, m 20 times. Okay, so m to the power of 20. And now we just put in the numbers. So having set up my before and after statement, I can say 1 million is equal to 150,000 times m to the 20. And to get the m bit on its own, we just divide both sides by 150,000. And that gives me, after the 150,000s have cancelled on the right, m to the power of 20 is equal to 1 million over 150,000. Now I'm not going to calculate that yet because I'm just going to put one thing into my calculator, which is the 20th root of 1 million over 150,000. And I hope you know how to use the nth root button on your calculator. I have done a revision video on using calculators, so do look at that. And if we do that, the calculator says 1.0995005. Now remember, that's a decimal equivalent, and it's the decimal equivalent of 109.95%. And so we just want the interest bit, which is what the increase, and so it's 9.95% interest per annum, or per year, if you like. I'm going to put PA for per annum. And there we go. So each time we've written down a before and after statement, and we've just solved the equation.